students, this is Bijay sir, your chemistry teacher. Today I have made a video for the students of class 10th under the first chapter, chemical reactions and equations. The topic is how can we identify the substance oxidized and reduced. I have taught you when we have started oxidation and reduction reaction, the basic definition of oxidation and reduction. I would like to revise the basic definition of oxidation and reduction both once again for your convenience. Oxidation and reduction are two parts of a chemical reaction. In oxidation, oxygen or any electronegative element is added to a substance, or hydrogen or any electropositive element is removed from the substance. The third way to define oxidation is the loss of electron by an element, and the fourth one is the increase in oxidation number or oxidation state or charge of an element. And reduction we can define just reversed of this process. Addition of hydrogen or any electropositive element, or removal of oxygen or any electronegative element, or gain of electron, or decrease in oxidation number or oxidation state or charge of the element is called reduction. To understand and identify the substance oxidized and reduced, we can apply any of these basic definition of oxidation and reduction. But the last two part of the definition, in which we use oxidation number and electronic concept to define the oxidation and reduction. Here I would like to use to make you easily understand that how can you decide or identify the substance oxidized and reduced by making a comparative table between these two parts of a chemical reaction, oxidation and reduction. Oxidation is a process. Reduction is also a process. The substance which undergo oxidation, the substance during a chemical reaction the substance which undergo oxidation is called oxidized, right? And the substance which undergo reduction is called reduced, right? Here, one term I would like to make you understand, which create confusion among the students to identify in the examination. When the question is asked as indicate the reducing agent and oxidizing agent in the following chemical reaction, then usually the student miss and confuse to identify the reducing agent and oxidizing agent correctly, because the substance which undergo oxidation or the substance which is oxidized is called reducing agent. And the substance which undergo reduction, the substance which is reduced due to the chemical reaction is called oxidizing agent. Oxidizing agent. These all three terms comparative you need to learn, you need to keep these all terms in your memory, because questions are asked either on the basis of the process, oxidation and reduction, or the language of question may be identify the substance oxidized and reduced, and question may be asked as identify or indicate the reducing agent and oxidizing agent in the following reaction. In any of the language, if questions are asked, you will be able to solve the questions correctly. Here, we use only last two part of our basic definition, that is loss of electron or increase in oxidation state is called oxidation. And here we shall use opposite of loss, gain of electron, or decrease in oxidation state is called reduction. Right? Now, to make you understand the substance oxidized and reduced, or the process of oxidation and reduction on the basis of loss of electron and gain of electron, I am providing here a word so that you will be able to keep these two processes in your memory easily. Loss of electron we can write in short LEO, loss of electron, is oxidation. Loss, L for loss, E for electron, O for oxidation. Loss of electron is oxidation, and G for gain, E for electron, and R for reduction. If you will remember, if you will keep this word Leo Z in your memory, then you will not forget to differentiate oxidation and reduction. Loss of electron, oxidation; gain of electron, reduction. And as I have taught you, the oxidation and reduction are the two processes, are the two parts of a chemical reaction. Now, understand the process of oxidation and reduction with the help of examples. Calcium reacts with oxygen to form calcium oxide. It is a chemical reaction in which both oxidation and reduction are taking place simultaneously. Therefore, this reaction is called redox reaction. Now, we shall bifurcate. We shall identify the process of oxidation and reduction separately. Calcium losses 2 electrons. As you know, the atomic number of calcium is 20, and if you will write the electronic configuration of calcium cell wise, you find 2, 8, 8, 2, means 2 electron in K cell, 8 electron in L cell, 8 electron in M cell, and 2 electron in N cell, 4th cell. And when these 2 electrons are lost by calcium atom, it acquired the nearest inert gas configuration like argon and becomes stable. This process is called oxidation, because here electron is loss. The loss of electron. And in the second part, oxygen gains 2 electrons per atom, but oxygen occurs in nature in the form of diatomic molecule. Therefore, it needs to gain 4 electrons to convert into 2 oxide ion. Here electron is gained by oxygen, therefore it is the process of reduction, and this in short we can write GER means gain of electron is reduction, and here LEO means loss of electron is oxidation. Here GER means gain of electron is reduction. Now, if we shall add these two parts of a chemical reaction algebraically, we need to make the number of electron lost and gained equal. And to make the electron equal, we need to multiply the first part of the reaction by 2, and then we add these two half reactions, and we shall have the reaction as we have written above. 2Ca plus O2, 2Ca, 2 plus ion, plus 2O, 2 minus ion. And you know, calcium and oxide ion are two oppositely charged ions. When these two oppositely charged ions are kept together, they linked due to electrostatic force of attraction to form an ionic compound which we write like CaO, calcium oxide. Right. Now, we can define this term redox reaction. In the previous video, I have already defined you, I have already taught you the term redox reaction. In this video, once again I would like to make you understand the redox reaction for your convenience. In a chemical reaction, oxidation and reduction take place simultaneously. Oxidation and reduction take place simultaneously. And they are together called redox reaction. Clear? Now, I am providing you some more examples of redox reaction so that you can have the clear concept of the redox reaction. Suppose a reaction is taking place at FeCl3 plus H2S to form FeCl2 plus HCl plus S. This is a chemical reaction. Here we shall understand how to decide the substance oxidized and reduced. For that we need to determine the oxidation state of each element in the both side of the reaction. Means in the each element of reactants and the products, we need to determine the oxidation state or charge of the element. The chlorine is halogen, and in a compound halogen, oxidation state of halogen is -1. If you will calculate the oxidation state of iron here, you will find +3. You may calculate it in the rough paper provided with your answer sheet in the examination as FeCl3 is a compound. The total sum of oxidation state of all elements in a compound is 0. We have to calculate the oxidation state of iron in this compound. Let the oxidation state of iron is X. Oxidation state of chlorine is -1 into 3. So X is equal to +3. And in this compound, both elements, the oxidation state of both elements, hydrogen and sulfur, comes under the rule we have read. The oxidation state of hydrogen in a compound and ion is +1, and the oxidation state of sulfur in sulfide is -2. Likewise, you determine the oxidation state of chlorine -1. Here iron you will calculate. It will +2, hydrogen +1, chlorine -1. And the first rule we have read, the oxidation state of all elements in the elemental state, means in the free state or in uncombined state, is always 0. So sulfur is in the form of an element, in elemental state, in uncombined state, therefore its oxidation state is 0. After deciding the oxidation state of each element in both sides of the reaction, you should look into the change in oxidation state. So see, in ferric chloride, the oxidation state of iron is +3 in the reactant side, and in the product side it is +2. It means the oxidation state of iron is decreased. The decrease in oxidation state is called reduction. The process is called reduction, or we can say ferric chloride reduced to form ferrous chloride. Reduced. And the substance which undergo reduction is called oxidizing agent. The if you will be asked to indicate the oxidizing agent, so you will write in this reaction ferric chloride is an oxidizing agent. Now, in the next reactant, sulfur, the oxidation state of sulfur undergoes change. It becomes 0 from -2. Means the oxidation state of sulfur is increased. Means H2S undergo oxidation. It is oxidized to form sulfur, and since H2S undergo oxidation, therefore it is a reducing agent in this reaction. Clear? Similarly, we can take another example. Say the reaction is P4, phosphorus, react with nitric acid, 20HNO3, to form phosphoric acid. What is the formula for phosphoric acid? H3PO4. Phosphoric acid plus NO2, brown fume of NO2 is released, 20NO2, and 4H2O. Right. In this reaction, we again similarly decide the oxidation state of each element in the reactant and each element in the product. After deciding the oxidation state, we shall again look into the change in oxidation state. And on the basis of change in oxidation state, we shall decide the substance oxidized and reduced. Here phosphorus is in elemental state, so the oxidation state of phosphorus is 0. In a compound or ion, the oxidation state of hydrogen is +1. The oxidation state of oxygen is -2. But we need to calculate the oxidation state of nitrogen in this compound. So you will calculate it on your rough paper. HNO3 is a compound, the total sum is 0. Let the oxidation state of nitrogen is -1. Let the oxidation state of nitrogen is X, and oxygen is -2 multiplied by 3 plus 1 plus X minus 6 is 0. X is equal to +5. So we shall indicate here +5. The oxidation state of nitrogen is +5. Likewise, you will calculate here oxidation state of hydrogen +1, oxygen -2. Calculate the oxidation state of phosphorus. H3PO4 is equal to 0. +3 plus X minus 8 is equal to 0. X is equal to +5. Here the oxidation state of phosphorus is +5. Here the oxidation state of oxygen is -2. Now calculate the oxidation state of nitrogen in this compound. Let X -2 into 2 is equal to 0. Therefore X is equal to +4. Here oxidation state of nitrogen is plus 4, hydrogen in water plus 1, oxygen minus 2. So we have decided the oxidation state of each element in the reactant side and the product side. Now look into the change in oxidation state. So the oxidation state of phosphorus changed in the reaction from 0 to plus 5. So what does it indicate? It indicates the oxidation state of phosphorus is increased. The increase in oxidation state, is oxidation. Therefore, phosphorus undergo oxidation to form phosphoric acid. We can say phosphorus is oxidized to form phosphoric acid. Therefore, phosphorus is a reducing agent in this reaction. Clear? Now, nitrogen undergo change. The oxidation state of nitrogen in nitric acid is plus 5, and in NO2 it becomes plus 4. Means oxidation state is decreased. The decrease in oxidation state is a reduction. We can say nitric acid reduced to form NO2. Right? So this is all about the concept of oxidation and reduction. With the help of these concepts, you can solve the question if you will be asked to identify the oxidizing agent and the reducing agent, or the substance undergo oxidation or reduction, or the substance oxidized and reduced in the given redox reaction. Okay, thank you.